right, welcome to lesson 3.6. We're going to talk about something called isotopes. Right, so there are two things you need to know. One is to be able to define what an isotope is and know that there are two different ways of writing isotopes. We call that isotope notation, and know that you need to know how to use the two different types of isotope notation in order to identify the number of protons, neutrons, and electrons for this thing called an isotope. Right. In the previous lessons, we talked about the structure of an element using a Bohr model and how they're made through fusion. In this lesson, we're going to talk about why certain elements might differ in their masses, and we call elements that are the same element with different masses isotopes. So before we start taking notes, I want you to see if you can figure out what elements do we make up top and what elements do we make down at the bottom. All right, so go ahead and pause this video and see if you can figure out what elements you make. Okay, so hopefully you were able to figure out that the two elements that we make are the same, and each time we're going to make beryllium. If you did not get that, I'm going to go over the steps of how I figured that out. And if you did get this, feel free to skip ahead to when I start talking about the next slide. Right? And you might also notice that the mass is 7 and this mass is 8. Okay. So if you didn't understand how we got 4 and 7 here, let's talk about each part. So remember I said the top number, imagine that it's one whole row straight across. And notice here I'm adding all of these things with these things, right? So here I'm still adding. So 3 protons. Remember our top number is the number of protons. Plus 1 proton will give me 4 protons. To figure out the mass, it's the same step. So here I have 6. This bottom number is our mass. So not just for the 6, but all of these, the 1 and the 7 too. So 6 plus 1 will equal 7. All right, so that's how I figured out the mass. Now, how did I figure out that this was Be? Well, once I figured out that my top number is my protons, remember the number of protons tells us what element it is. So if I know that I have 4 protons, I'm going to check my periodic table. So we're going to use ptable.com, and I'm going to look for an element with the top number of 4, right? So to make this extra clear, as I'm scanning through these elements, I'm looking at all their top numbers, looking to see which one is 4, right? So they go in order 1, 2, 3, and this one's 4. So element number 4 is going to be Be beryllium. So that's how I figured out this is Be beryllium because it has 4 protons and it matches with this one, 4 on top, Be, right? Or beryllium if you want to write out the whole name. So to do the bottom part, I did the same exact steps, right? This time this is 2 plus 2 will give me 4. So 4 protons, it's still Be beryllium. But this time, notice your mass is different. So here, 4 plus 4 equals 8. So these two things we call isotopes. Isotopes are things that are the same elements but have different masses. And the reason why they have different masses is depending on what elements are crashing into each other in a star, right, will end up with things with the same number of protons, but maybe slightly different number of neutrons. So let's formalize this in our notes in the next slide. Okay, so your notes might look something like this. Isotopes is your title. Here's our objective, right? Here I have a different example. So notice that I drew out the nuclei or the nucleuses of each atom. If I have hydrogen and helium, right? 1 protons, 2 protons atom together, I will end up with 3 protons and a mass of 1, 2, 3, 4. So 4 is my mass in this case, right? I know this is going to be lithium because the top number is 3 here and the top number is 3 here. So I match them. Third one is Li or lithium. So this is lithium, right? And for this one, if these two crash into each other, 1 proton plus 2 protons will still give me 3 protons, right? So this is still Li. But if I look at the neutrons, these ones had 2 neutrons. These ones have 2 neutrons, so if I add up all of the masses together, it doesn't add up to 4 this time, it adds up to 5. 1, 2, 3, 4, 5. So 5 neutrons and protons make up my mass. So both of these are lithium, but their masses are different. So this is what we call isotopes. All right, so this goes in your notes. Isotopes are elements that share the same number of protons. Same number of protons. This should actually be in blue. But different number of neutrons. Right, so if you notice here, this one only has 1 neutron. This one has 2. So different number of neutrons. If you want to be extra clear in your notes, you can also say, in addition to different number of neutrons, because they have different neutrons, they also have different masses, right? Okay. So there are 2 ways to show an isotope, right? Normally, when we write things like this way, we're talking about an element in general. So what an average element looks like. When we're talking about isotopes, we're talking about a specific kind of element, exactly one kind of element. Okay, so on the periodic table, when you look at the periodic table, you'll see top number is protons. I'm going to drill this into your brain. Bottom number is going to be your mass, right? And that's the number of protons plus neutrons, right? And this is for all types of nitrogen. So some nitrogen might weigh 14, some nitrogen might weigh 13, right? So in this isotope or this version of nitrogen, this one, you'll notice that things are kind of weird. Before I tell you where everything is, can you guess which one is actually the proton and which one is the mass? Okay, so you might notice that when we're talking about an isotope or a specific kind of elements, okay, so let me note that. When we're talking about isotope notation, we're talking about a specific type of elements, right? It might have its own mass different from what you see on the periodic table. So when we're talking about this one type of nitrogen, you'll notice that the mass on this time is written on top. It's a little confusing. And the number of protons is written on the bottom. So if you notice that this is flipped, that means we're talking about one kind of elements or one type of nitrogen, right? So here, these two examples come from your homework, right? So if I give you one specific isotope notation, how do I figure out how many protons, neutrons, and electrons there are? Well, it's the same thing as we did with the periodic table, just flipped, right? The numbers are just, this one is on the bottom instead of the top, right? And this one's on the top instead of the bottom now. So if I want to know how many protons I have, well, it's same as before, right? So this time I have 7 protons. How many electrons do I have? Well, let's do that first. We're going to assume that all of these are neutral elements, meaning the number of protons I have is going to be the same as the number of electrons that I have. So if I have 7 protons, I will also have 7 electrons, as shown by this bottom number. How many neutrons do I have? Well, from the top number, I know that my mass is 13, right? And my mass is made up of protons plus neutrons, right? So protons plus neutrons. So I know from this bottom number, I have 7 protons. So 13 equals 7 plus some number of neutrons. So I can think to myself, 7 plus what equals 13? Or I can do 13 minus 7 will give me the number of neutrons, right? So in this case, it would be 6. So here I have 6 neutrons, right? So in this version, it's pretty much the same as what we did before in previous lessons, except the bottom number is now on top and the top number is now on the bottom, right? There's a different way of writing an isotope as shown here, right? So sometimes it'll show the name, the full name dash 25, right? So in this case, it doesn't show you the number of protons, it shows you just the elements, magnesium, and this number is the mass, right? So using the same colors, this one now is my mass, right? So if I were to work backwards, right, it's kind of trickier if I give you this one because, well, like, how do I know how many protons do I have? So if it's written in this way, you have to use your periodic table, right? So looking at this one, I'm going to have to search for magnesium or the full name of magnesium up top. Right, so I'm going to look for an element that says magnesium starting from left to right, straight across. Keep looking, second row, don't see magnesium, third row, haha, here it is, magnesium. So if I look up magnesium, I'll notice that this has 12 protons. This should actually be in blue. So 12 protons. So now I can go back in here, right? 12 protons. So I know that I have 12 protons for this one. And if I'm given this version, I need to look it up on the periodic table. I'm just going to write P table for short, right? So because I know the number of protons that I have, I can also figure out the number of electrons that I have, right? Because remember that the number of protons that I have is the same as electrons. So if I have 12 protons, I have 12 electrons. Okay, so now that I looked up on the periodic table how many protons I have, figured out how many protons I have and electrons I have, I can use this mass number of 25 to figure out how many neutrons do I have, right? Okay, so just like before, my mass is 25, and I know from earlier that mass is just protons plus neutrons. I know from the periodic table, I had 12 protons from the top number, plus how many neutrons do I have? Well, I'm not sure. I have to figure that out algebraically, right? So I can either think what plus 12 equals 25, or let me write it on the side here, or I can think 25 minus 12 would be what? Well, 5 minus 2 is 3, 2 minus 1 is 1. So here, I should actually have done this in orange because this is my number of neutrons. So I have 13 neutrons, right? So when we're talking about one specific element, we call that an isotope. There are two ways of writing an isotope, this way or this way, right? So what notes should I take from here? I would definitely label the mass, what counts as the mass, what counts as your protons and electrons, what counts as the mass here, and then how you figure out the number of protons for this one and electrons, right? We have to look it up on the periodic table, right? This one's a little bit trickier. So those are the two ways we can identify isotopes. Now, let's see if you can do these ones on your own. So go ahead and pause the video and see if you can do these two on your own, and I'll tell you the answers for these ones. Okay, so for this one, remember this is my mass. This one is the number of protons, and it's also the number of electrons. Right, so here I'm going to have 2 electrons, 2 protons. How many neutrons will I have? Well, remember our mass equals protons plus neutrons. So if our mass is 4 from this number, and my protons is 2 from the bottom number, this number, 4 equals 2 plus what? Right? Or what plus 2 equals 4? Well, 2 plus 2 is going to be 4, so I'm going to have 2 neutrons. If this was too fast, feel free to go back on the previous slide where I talked about the first problem and I slowed things down. So here, the second one, carbon. I know this is carbon, and I also know that this number back here is the mass, right? But since it's written with a full name, I need to look up how many protons carbon has. So let's check my periodic table and let's look for carbon. So usually as a habit, if I don't have these memorized, I'll start from the upper left, kind of look straight across, looking for carbon. Boom, there it is, carbon. Right, so if I click on this, let's make it bigger. So this carbon has 6 protons because the top number is 6. Right. So therefore, protons is going to be 6. How did I find this? Look up on the periodic table. And as mentioned before, same number of protons is the same number of electrons. So if I have 6 protons, in this case, I'm also going to have 6 electrons. So here, now that I know my protons, I can figure out how many neutrons I have. Remember, our mass is always made up of the same two things, protons plus neutrons. So let's write out that equation again, equals P plus N. Hopefully I'm boring you to death because this is the same thing over and over, in which case feel free to fast forward. Mass is 14. How many protons we got? We got 6 protons from our periodic table. 6 plus how many neutrons? Well, what plus 6 equals 14? Or I can think of this as 14 minus 6 will be what? Well, 14 minus 6 is going to be 8, right? If I plug this in, 8 plus 6 equals 14. Oh my gosh, I'm going to have 8 neutrons. All right, so hopefully that helps. And you should be ready for your mini quiz questionnaire on Nearpod on the next slide.